Hello, our project is a saxophone mouth mold to prevent scars and future health problems. I'm Evan Brush,
I'm willing to.
and this is our Modern Biomedical Engineering project. Saxophone playing requires continuous contact between the mouthpiece and the lips. This often means that bottom lips are between the mouthpiece and teeth. Having the lower lip placed between the teeth and mouthpiece creates constant pressure, mainly from the bottom teeth during a playing session. Over long sessions, this can cause irritation, soreness, scarring, and in some instances, bleeding. Repeated mechanical stress on the lips from the teeth causes permanent musculoskeletal damage and soft tissue damage, affecting ability to play properly in the future. Proper embouchure is often implemented to attempt to solve this pressure, which requires resting the top teeth on the mouthpiece and creating a cushion with the lower lip over the bottom teeth, sealing corners of the mouth inward. However, if your teeth are sharp, this problem occurs even with proper embouchure. Also, if you are a new player, you can cause damage unintentionally due to inexperience with proper form. Current solutions, such as a mouthpiece cushion, are designed to attempt to resolve this problem, protecting the teeth with a small pad during playing. However, these cushions only provide limited improvement and are only designed to protect the teeth rather than reduce pressure on the lower lip, which is the main area affected. Additionally, these cushions are not customized to the individual, meaning they do not effectively distribute pressure across the lip. Our product introduces a custom fit mouth mold design that fits between the teeth and the lips, protecting the user from previous mentioned lip damage. By increasing contact surface area between the teeth and the bottom lip, the design reduces concentration of pressure for potential damage to the lip and the surrounding tissue. By distributing force in a larger area and more evenly, the risk of irritation and long-term damage should be reduced. The design is made of polycaprolactone, allowing the product to be molded to fit the player's teeth whilst maintaining structural integrity after molding under warm conditions. Using polycaprolactone for our design also introduces a simple and low-cost design, as well as non-toxic and biodegradable properties.
Right. So our results. The mold shown on the side is made using PCL. Testing took place over 2 weeks for 1 hour a day for 3 days in a row. Over the experience, there was overall less fatigue and overall less pain. The testing was done by me and someone else that I know that plays the saxophone. They have not played in many years, and their main result was also less fatigue and less pain to get started again. However, this also gives a very limited sample size and timing as well, since it was 2 weeks and 2 people. The bad and recommendations. For the bad, it was harder to maintain a good tone as shown in the earlier video. Testing was not long-term, and for what we can see is that there is a risk of becoming dependent and you won't be able to develop your embouchure. So overall, this slows down your development and could cause a overall reliance on it in the future and won't improve as a player overall. For recommendations, we recommend to not use as a replacement, but use as something to use in those long practice sessions where you can't keep playing, but you need to, and this is just a secondary measure. And also, it's recommended that if you're going to use this solution, you should have more practice as well, since, like shown in the video, it took me quite a while to get back into tune for playing. For our future work, we want to make it to be able to use it on the move, since obviously you can't just have hot water everywhere. So our solution to that was maybe using the aluminum magnesium alloy and water, like what MRE uses, to have hot water anywhere and be able to mold it anywhere you want. Or we could have a container like the ones you use for dentures for water pieces with cleaner in the containers. However, we would also like more testing for the future and more time as well to ensure the quality and look into more material types, since this material type is technically expensive if you're not getting it elsewhere. If you buy it from like American companies, it'll cost upwards of $50 to $100, but from other companies, it costs like $1 or $2. These are our references.